So in the last chapter, we looked at exponential growth, which this purple graph right here shows exponential growth. When we find the inverse of something, we switch the x and the y. When we switch the x and the y, what we're really doing is we are reflecting the line, we're reflecting the curve over the line y equals x. So this is the line y equals x. If we switch the x and the y coordinates, we end up getting this thing that looks like this. Do you see how that looks symmetrical over that diagonal line? So if this coordinate was like 1, 2, then this coordinate would be 2, 1. The x and the y's are switched. In exponential growth, you have an asymptote at y equals 0. You have a horizontal line asymptote. With logarithms, you have a vertical line asymptote. X and y switch. So if it was y equals 0, now the asymptote is going to be x equals 0. So logarithmic functions have an asymptote that is a vertical line. So that makes an equation that is x equals. And originally, it's x equals 0. It's right on the y-axis. So on each of these graphs, I want us to look at where is the asymptote, what is the domain, and what is the range. The asymptote of this first one is still the y-axis. So the asymptote is the line x equals 0. The domain refers to the x values, so this time the domain and the asymptote are going to be linked together. The domain is x is greater than 0. All of the x values on this graph are bigger than 0. This x value, this point has an x value of 1. This point has an x value of 4. This point has an x value of 6. I don't know what the y value is. Looks like 2.5. But all of those x values are bigger than 0. The graph is on the right side of the asymptote, so the domain is x is greater than 0. When we did exponential graphs, the domain was the all real numbers. That's going to flip because we're switching the x and the y. So the range is going to be all real numbers. So for logarithmic graphs, the range is the easy one. That's the all real numbers because it's switched from exponential. The domain is tied to the asymptote. Take a look at number 2. This asymptote is here. The asymptote used to be at 0. The asymptote moved left 2. Do you see anything in that equation that would indicate a movement left 2? This plus 2 moved the entire graph left 2. And because the graph moved left 2, the asymptote is now x equals negative 2. The domain, all of the x values, all of the points are on the right side of that asymptote, so x is greater than negative 2. And then the hardest part, I'm being incredibly sarcastic. What is the range? All real numbers. On the test, it's very likely that for range, you can just type in a capital R and that will suffice for all real numbers. So really, on all of these, you could go through right now and write in that the range is all real numbers because that's going to be the same for every single log graph. In fact, you might want to write in your notes somewhere, for logs, range is all real numbers. Oops, I don't want to cut that out. Number 3. This time the asymptote is here, It was at 0, it has moved right 2. And notice that plus 2 tells us right 2. So whatever number is inside the parentheses, inside the log with the x, that tells you the horizontal movement, and it's backwards. Plus means left, minus means right. Our asymptote would be at x equals positive 2. Anyone want to take a guess what the domain might be? Okay, this class is not very... x is greater than 2. All right, let's look at the next one. This time, there's nothing inside with the x. There's only numbers outside. So number 5 is actually very, very similar to number 1. Do you see how number 5 and number 1 look almost identical? It's just log base 3 instead of log base 2. So the asymptote is at x equals 0. The domain is x is greater than 0. And the range is all real numbers. How has number 6 changed from number 5? The asymptote's still at 0. I'm going to look at this point right here. That point looks like it's 5, 1.5. This point is 5, negative 0.5. That point used to be here. It moved down 2 units. This minus 2 indicates that the graph moved down 2. Now, with a vertical line, if you move a vertical line up and down, it doesn't change where that line is. So our asymptote is still at 0. Our domain is still x is greater than 0. And our range is all real numbers. Number 7, if you look at that point at x equals 5, instead of being here, it has moved up 2. So this plus 2 means up 2. Hasn't changed the asymptote, hasn't changed the domain, hasn't changed the range. So 5, 6, and 7 are kind of boring because the asymptote, domain, and range have not changed. So far, we've basically looked at what happens if there's something added or subtracted inside the parentheses and what happens if there's something added or subtracted after. If it's inside the parentheses, plus means that the graph moves left, minus means the graph moves right. The plus k, plus moves the graph up, minus moves the graph down. Number 9, this graph we've already seen. This is log base 2 of x. Our asymptote is 0. Our domain is x is greater than 0. Our range is all real numbers. The only difference between A and B is that there's a negative inside the parentheses. A negative inside the parentheses is going to flip the graph over the asymptote and make this on the left side of the asymptote instead of on the right side. It hasn't changed where the asymptote is, but now the domain is going to be x is less than 0 because the graph is on the left side of that asymptote. Compare C to A. It has flipped over the y-axis. This is a vertical flip. So B is a horizontal flip. C is a vertical flip. The nice thing is you're going to see vertical flips more than you see horizontal flips, and vertical flips really don't change anything on this graph, except for like the shape of the graph. The asymptote is still at 0. The graph is still on the right side of that asymptote, so our domain is still x is greater than 0, and our range is still all real numbers. Tomorrow, I'm going to show you graphing both on the TI-84 calculator and on Desmos. For today, really all you're doing in your assignment is taking problems like number 10. So we're going to do number 10 together. But here's what your assignment will ask you for. It will ask you, sorry, I had to check my terminology. it will ask you for horizontal movement, vertical movement, and then it will ask you for the asymptote, domain, and the range. So in this particular example, the +4 inside the parentheses indicates that this graph is going to move left 4. Remember, horizontal movement is backwards, so plus actually means left. The +2 is going to tell us that the graph moves up 2, not 4, up 2. The asymptote and the domain are tied to this horizontal movement. So because the graph moved left 4, your asymptote is going to be at x equals -4. Your domain, I don't see any negatives in there, so it's not going to flip anything around. So your domain is going to be x is greater than -4. And then anyone want to take a guess on the range? All real numbers. That's basically all you have to do on your assignment today. Horizontal movement, vertical movement, what's the asymptote, what's the domain, what's the range. If you want to stick around on the video, I am going to show you briefly how to graph this on Desmos in case you want to check all of that. But if you feel like you're good, you can stop the video and start working on your assignment. When you go to desmos.com, click on the graphing calculator. Over on the left side, you can type in whatever you want it to graph. So the one that we just looked at was y equals, you need the y equals. Type in log, and it changes, like when you start typing log, it looks like italic. But as soon as you hit the G, it turns it straight because it changes that into the log function. To get the base, you push Shift and your dash button. That's like the underscore button. That moves it down into the subscript so that you can put in your base of 3. Use the right arrow to get out of that subscript, and then you can do parentheses x plus 4. Close your parentheses. +2. And then that will show you the picture of the graph. Then you can zoom out, you can manipulate it however you want to see that your asymptote is at -4 and that your graph is on the right side of that asymptote, which means that your domain is going to be x is greater than -4. Also, it's a little bit off of my screen right now, but down at the bottom corner, it says Show Keypad. You can click that, and then it gives you some options that are more similar to what you're used to seeing on EdSite and Big Ideas. And you'll notice that log isn't in these options, but if you click on functions, there's a whole bunch of functions here, and you can kind of click through until you find the one you want. I think log is in miscellaneous. And there's plain log and there's log base A. So if you were going to do another equation here, you could find, where's my mouse? You could click on those functions, go to miscellaneous, and then you could click log base A, and then it already puts you down in that subscript. The only crazy thing is we forgot the y equals, but that's another way that you can get all of that entered if you want to. But I think the easiest is typing log, Shift, dash, and then you can type it in. So if you want to graph it on Desmos, that is how you do it. But really today, all you're doing is horizontal movement, vertical movement, asymptote, domain, range. Let me know if you need any help with anything.